Venus is the second planet from the Sun. It is named after the Roman goddess of love and beauty. As the second brightest natural object in the night sky after the Moon, Venus can cast shadows and can be, on rare occasion, visible to the naked eye in broad daylight. Venus lies within Earth's orbit, and so never appears to venture far from the Sun, either setting in the west just after dusk or rising in the east a bit before dawn. Venus orbits the Sun every 224.7 Earth days. With a rotation period of 243 Earth days, it takes longer to rotate about its axis than any other planet in the Solar System and does so in the opposite direction to all but Uranus, meaning the Sun rises in the west and sets in the east. Venus does not have any moons, a distinction it shares only with Mercury among planets in the Solar System. Venus is a terrestrial planet and is sometimes called Earth's sister planet because of their similar size, mass, proximity to the Sun, and bulk composition. It is radically different from Earth in other respects. It has the densest atmosphere of the four terrestrial planets, consisting of more than 96% carbon dioxide. The atmospheric pressure at the planet's surface is 92 times that of Earth, or roughly the pressure found 900 m, 3,000 feet, underwater on Earth. Venus is by far the hottest planet in the Solar System, with a mean surface temperature of 737 K, 464 degrees Celsius, 867 degrees Fahrenheit. Even though Mercury is closer to the Sun, Venus is shrouded by an opaque layer of highly reflective clouds of sulfuric acid, preventing its surface from being seen from space in visible light. It may have had water oceans in the past, but these would have vaporized as the temperature rose due to a runaway greenhouse effect. The water has probably photodissociated, and the free hydrogen has been swept into interplanetary space by the solar wind because of the lack of a planetary magnetic field. Venus's surface is a dry desertscape interspersed with slab-like rocks and is periodically resurfaced by volcanism. As one of the brightest objects in the sky, Venus has been a major fixture in human culture for as long as records have existed. It has been made sacred to gods of many cultures, and has been a prime inspiration for writers and poets as the morning star and evening star. Venus was the first planet to have its motions plotted across the sky, as early as the 2nd millennium BC. As the planet with the closest approach to Earth, Venus has been a prime target for early interplanetary exploration. It was the first planet beyond Earth visited by a spacecraft, Mariner 2 in 1962, and the first to be successfully landed on, by Venera 7 in 1970. Venus's thick clouds render observation of its surface impossible in visible light, and the first detailed maps did not emerge until the arrival of the Magellan orbiter in 1991. Plans have been proposed for rovers or more complex missions, but they are hindered by Venus's hostile surface conditions. In January 2020, astronomers reported evidence that suggests that Venus is currently volcanically active. Physical characteristics. Venus is one of the 4 terrestrial planets in the Solar System, meaning that it is a rocky body like Earth. It is similar to Earth in size and mass, and is often described as Earth's sister or twin. The diameter of Venus is 12,103.6 kilometers, 7,520.8 miles, only 638.4 kilometers, 396.7 miles, less than Earth's, and its mass is 81.5% of Earth's. Conditions on the Venusian surface differ radically from those on Earth because its dense atmosphere is 96.5% carbon dioxide, with most of the remaining 3.5% being nitrogen. Internal structure. Without seismic data or knowledge of its moment of inertia, little direct information is available about the internal structure and geochemistry of Venus. The similarity in size and density between Venus and Earth suggests they share a similar internal structure, a core, mantle, and crust. Like that of Earth, the Venusian core is at least partially liquid because the two planets have been cooling at about the same rate. The slightly smaller size of Venus means pressures are 24% lower in its deep interior than Earth's. The principal difference between the two planets is the lack of evidence for plate tectonics on Venus, possibly because its crust is too strong to subduct without water to make it less viscous. This results in reduced heat loss from the planet, preventing it from cooling and providing a likely explanation for its lack of an internally generated magnetic field. Instead, Venus may lose its internal heat in periodic major resurfacing events. Atmosphere and climate. Venus has an extremely dense atmosphere composed of 96.5% carbon dioxide, 3.5% nitrogen, and traces of other gases including sulfur dioxide. The mass of its atmosphere is 93 times that of Earth's, whereas the pressure at its surface is about 92 times that at Earth's, a pressure equivalent to that at a depth of nearly 1 kilometer, 5.8 mi, under Earth's oceans. The density at the surface is 65 kg/m3, 6.5% that of water or 50 times as dense as Earth's atmosphere at 293 K, 20 degrees Celsius, 68 degrees Fahrenheit, at sea level. The CO2-rich atmosphere generates the strongest greenhouse effect in the solar system, creating surface temperatures of at least 735 K, 462 degrees Celsius, 864 degrees Fahrenheit. This makes Venus's surface hotter than Mercury's, which has a minimum surface temperature of 53 K, 220 degrees C, 364 degree F, and maximum surface temperature of 700 K, 427 degrees Celsius, 801 degrees Fahrenheit, even though Venus is nearly twice Mercury's distance from the Sun and thus receives only 25% of Mercury's solar irradiance. This temperature is higher than that used for sterilization. Venus' atmosphere is extremely enriched of primordial noble gases compared to that of Earth. This enrichment indicates an early divergence from Earth in evolution. An unusually large comet impact or accretion of a more massive primary atmosphere from solar nebula have been proposed to explain the enrichment. However, the atmosphere is also depleted of radiogenic argon, a proxy to mantle degassing, suggesting an early shutdown of major magmatism. Studies have suggested that billions of years ago, Venus's atmosphere could have been much more like the one surrounding Earth, and that there may have been substantial quantities of liquid water on the surface, but after a period of 600 million to several billion years, a runaway greenhouse effect was caused by the evaporation of that original water, which generated a critical level of greenhouse gases in its atmosphere. Although the surface conditions on Venus are no longer hospitable to any Earth-like life that may have formed before this event, there is speculation on the possibility that life exists in the upper cloud layers of Venus, 50 kilometers, 30 miles, up from the surface, where the temperature ranges between 303 and 353 K, 30 and 80 degrees Celsius, 86 and 176 degrees Fahrenheit, but the environment is acidic. Thermal inertia and the transfer of heat by winds in the lower atmosphere mean that the temperature of Venus's surface does not vary significantly between the planet's two hemispheres, those facing and not facing the Sun, despite Venus's extremely slow rotation. Winds at the surface are slow, moving at a few kilometers per hour, but because of the high density of the atmosphere at the surface, they exert a significant amount of force against obstructions, and transport dust and small stones across the surface. This alone would make it difficult for a human to walk through, even without the heat, pressure, and lack of oxygen. Above the dense CO2 layer are thick clouds consisting mainly of sulfuric acid, which is formed by sulfur dioxide and water through a chemical reaction resulting in sulfuric acid hydrate. Additionally, the atmosphere consists of approximately 1% ferric chloride. Other possible constituents of the cloud particles are ferric sulfate, aluminium chloride, and phosphoric anhydride. Clouds at different levels have different compositions and particle size distributions. These clouds reflect and scatter about 90% of the sunlight that falls on them back into space, and prevent visual observation of Venus's surface. The permanent cloud cover means that although Venus is closer than Earth to the Sun, it receives less sunlight on the ground. Strong 300 km per hour, 185 miles per hour, winds at the cloud tops go around Venus about every 4 to 5 Earth days. Winds on Venus move at up to 60 times the speed of its rotation, whereas Earth's fastest winds are only 10–20% rotation speed.